My name's Joshua Letcher. I've been in the resources industry for about 16 years now. Through that time, I've worked at various mine sites in Western Australia as well as in Africa. I've worked from basic roles, doing maintenance fitting, through to establishing resources through exploration, as well as developing mine sites. In my mid-20s, I took a break from the resources industry and joined the Navy. I worked as a submariner for the Royal Australian Navy and did mechanical role there for a few years. After the Navy, I went on to develop my own resource companies, starting with a diamond company in West Africa, which was quite exciting, and then came back to Australia and pursued a career in innovation through technologies and technology development, which led on to setting up Space Industries. Space Industries is a wholly owned Australian company and also veteran owned. The company was founded in 2019. Space Industries was formed off the background that I have in the resource industry as well as in the submarines, and the submarines I think was the spark for looking at the space industry. Being on board a submarine in the bottom of the ocean sort of feels like you're on the International Space Station. So that progressed me into that industry, and then with the resource background I decided to focus on critical resources for space. So what we did is we looked at what resources we can produce in space to solve space problems, so water on the moon, and also resources that we can produce in space that Earth doesn't have, and that led us to critical resources being helium-3 and water. Space Industries is developing the Lunar Resource Extraction Vehicle, which is our flagship mission to produce water on the Moon and Mars. In doing that, we're developing a number of technologies, which includes a large 3D printer, which is designed to print polyether ether coatine, or PEEK. That's a replacement for nylon and Teflon. So oil and gas industry as well as defence can utilise that 3D printing capability to improve composite materials as well as better thermal insulation. Some of the other technologies we're developing for the main flagship mission is the fuel transfer port, which has capabilities for subsea operations for transferring power as well as transfer of power and fluids on the move, so in air or while vehicles are moving. And that also has applications for satellites as well as transfer of resources like water or gas and power on the Moon and Mars. Some of the other products we're developing for Earth-based applications coming from our resource extraction vehicle is the mining processing method. So we've been able to put that together in a way that allows us to process and capture ores on Earth, and we can capture all of the emissions from those ores, as well as separate various minerals from the ore in a new method. One of the things for Space Industries with the space side is that we're looking to acquire offtake agreements. So basically we deliver the resource and the customer pays for it, and we put that into an agreement, similar to how the Earth-based industry works. So we've got a couple customers already lined up, one for space water and also one for space helium-3. We've also got a few other potentials, and we're looking at discussing with NASA for the supply of water on the Moon. So one of the reasons why we came up with mining helium-3 on the Moon is that helium-3 is very scarce. The only way that we produce that on Earth is by making nuclear weapons. There's a couple other methods like using nuclear power plants, but it's not economical. Helium-3 is very important. It's used in MRI scanners to keep the magnets cool. It's used for MRI imaging, so you inhale the helium-3 and it can give super high resolution images of your lungs to detect different diseases. And it's also used for neutron detectors, so the oil and gas industry, they'll wear a little device on them called a neutron detector, which helium-3 is stable and non-radioactive, so it's the only isotope that can be used for that. That can also be used for national security. So the USA depleted their helium-3 reserves after 9/11. They put neutron detectors around all the borders, so seaports, airports, and also in cities. So they're two of the biggest applications. The biggest future application is nuclear fusion energy. So over the last couple of years, that's had some pretty big advancements, and we're looking to see that commercialised hopefully over the next few years. And with very limited supply on Earth, the supply for helium-3, which is the fuel for nuclear fusion, needs to come from the Moon. For the last couple of years, so even before incorporating, we've been working on a new mining method to produce the helium-3. So the helium-3, we first looked at how does it get to the moon. It's deposited from the sun's radiation. So the sun deposits its radiation into the lunar surface. The helium-3 gets captured inside the small pockets inside the ilmenites. Those ilmenites are also associated to titanium. So for future production of structures on the moon, it's also a good location focused on the titanium and the helium-3. So we can do multiple things at once. With that as well, when the sun deposits its radiation, it's depositing protons into the surface. Those protons combine with electrons and form hydrogen. Already in the lunar regolith is about 43% oxygen. So the oxygen and the hydrogen come together and it forms water inside the lunar regolith, which is the soil on the moon. That's bonded with silica. So the natural environment heats to around 140 odd degrees, which is not enough for that water to break the bond from the silica and release. So we focused our mining method on producing water that's hydroxyl inside the regolith, which means also we can produce water anywhere on the lunar surface, which has had the sun exposure. So what we do is our vehicle heats up the regolith in a continuous mining method. So we don't use a traditional mining method where it's stop and start, or you have to drive from one location where you process to the mine site, extract it, transfer it all the way back. That's very inefficient. So what we do is we have an onboard storage. We heat the regolith to a certain temperature. That then outgasses all of the isotopes. So the bond is broken, the water releases as steam. We then capture the steam, use temperature and pressure to convert it back into water, and there you go, we've got water. So that's the process of how our vehicle works. Space Industries has a lot of export potentials. So a lot of the technologies we're developing, obviously with the 3D printer, transfer ports, have a lot of Earth-based applications. A lot of the larger companies in Australia are multinational and operate in countries like the USA and Europe as well. So there's a lot of export potential for those products. Our company has achieved good traction in the industry. We were selected as a final top 10 company by NASA iTech and presented to subject matter experts in Las Cruces in America, and that got us some pretty good traction. We've also been selected as a finalist for 2 of the Australian Space Awards, which was finalist for Innovator and also Startup of the Year as well. Within the defence industry, I think that Space Industries can offer the capability of the lunar resource extraction vehicle with its autonomous and semi-autonomous capabilities and its mobile drive system methods to accommodate harsh environments. I think it could be deployed in military situations or disaster relief situations as well that the military participates in. Yeah, one of the benefits to the space industry is it's predominantly remotely operated. So there's a lot of transfer back to Earth for remote operations and for our vehicle to be remotely operated for a number of different industries here in Australia. WA has a big opportunity with the space industry. It's got the resource sector, which already has a lot of capabilities for remote operation, but it also presents itself as a big customer to space companies looking at doing remote operations. The overall space industry in Australia is rapidly growing. Obviously, we've had the formation of the Australian Space Agency, and over the next couple of years, there's some pretty big funding opportunities. So hopefully we'll see a number of startups and SMEs rapidly growing from utilising a lot of those funds through those grant opportunities. The key goals for the company in the short term is to commercialise some of our Earth capabilities. So the 3D printer at the end of this year, 2021 being the fuel transfer port, as well as the lunar resource extraction vehicle for Earth applications, such as producing water in harsh environments from the sand. For the long-term objectives, we're planning on commencing the flight certification and flight vehicle from next year. So that'll be an increase in our team and the development team there. And going forward, we're looking at doing some trials with NASA over the next couple years, as well as launch target for 2023, which will be closer to the end of 2023, subject to launch availabilities. The future for space industries, I feel, is quite promising. We're in a good location here in Australia. We've got good support globally from various agencies that we've been speaking with, as well as some pretty good primes, big companies in the industry as well. We are looking to expand into the defence sector and looking to now engage the defence sector and see what support we can get there as well. Lunar processing presents some pretty big opportunities for the resources sector. We're currently doing tests with a few universities in Australia to confirm our space resource processing method for Earth applications. And that has some pretty big solutions to some of the biggest problems that are targeted at the moment. One of those being the reduction of emissions by 2030. So with our processing method, we're able to capture up to 100% of the emissions, and that presents a pretty big solution for the resource industry.